Hello, Pre-Algebra. This lesson is a supplement to the Pythagorean Theorem lesson. We're going to be discussing Marty's method of proving the Pythagorean Theorem. Like I said in the last lesson, he's got the good bare bones of what you would need. Here, I'm labeling a few things, color coding it, making it a little bit easier to see why this does indeed prove that a squared plus b squared is equal to c squared, which is the Pythagorean theorem. Okay, so the first thing to mention is that this square and this square are equal. So square 1 and square 2 are equal. That means all the area of this square has to add up to all of the area of this square. That is key for this proof. And it should be evident based on the size, but also they're drawn to scale. Next, it is key to understand that these triangles have never left the square. They're the same size. The pink polka dot one moved over, the yellow triangle moved up, so these went up in the top right, and this orange wave one went down to the purple line one. These are all the same size. All they did was moved in the inside the square. So the second thing to keep in mind is that the area of square 1 and area of square 2 are equal. The area of triangles in square 1 are equal to the area of triangles in square 2. What does that mean? Has to be the same with these three, or these empty spaces, so to speak. Well, if this area and this area are equal, and we haven't lost or gained any area by the triangles, well, then the area not covered by triangles must be equal. That's the key part of this. Area not covered by triangles are the same. Well, then let's talk about what these areas are. The area of this big center one has a length and a width of c. Each of these are c. That is the hypotenuse of our right angle triangle. Therefore, the area of this one must be c squared. That's the area of that square, is c squared. Moving over to the other side, it's the area of this little square right here. Well, it's got this side is a and this side is a, so therefore this area must be a squared. Finally, this is the long leg of the triangle. That's b and b, so the area of this one must be b squared. So what we have here is we have that the combined area of a squared and b squared has to equal the area of c squared. And there, we just proved it. A squared plus b squared is equal to c squared for any generic right angle triangle A, B, and C. As long as C is defined as the hypotenuse, a squared plus b squared is equal to c squared. That is Marty's method.